welcome to this week's episode of Automated. I, of course, am your host, Stefan and sitting next to me, freezing, with a Polymath Robotics shirt under a cuddled up leather jacket, is a gentleman who can't stop giggling. Sir, who are you and why are you here?
I don't know. Nicole put me in an icebox.
Yeah, this is freezing. I was making jokes about being Jennifer Aniston earlier, and no one even thought that was weird. It's how cold it is in this room. After we froze Adrian from Foxglove to death last week.
We heated him.
Heated him to death. Yeah. The heat death of the universe. It's actually what's happening right now because it's cold.
I think this is classic example of humans trying to be controls.
Yeah.
Because, 5 people in a room, too hot, should make it colder. Try again. 2 people in a room, very cold. Freezing to death. But controls is easy to solve problems. Yeah. Try an algorithm, it'll be fun.
I, of course, am Stefan. This is Automated. This is our weekly podcast that we've actually recorded 2 weeks in a row. And now we're now 4 weeks in a row. And we even are now on our 3rd video episode, and our lighting is getting better. I hope I finally do not look shameful to my ancestors.
It's certainly getting brighter.
Yes.
I have a feeling that by the end of this year, we'll just be staring into the face of the sun.
It will be fine. So this is our weekly robotics podcast where we talk about things in robotics and autonomy, challenges in them, and we make up some robots along the way. Ilia, what are we going to talk about this week?
Our main theme is probably going to be about collision avoidance systems and mines.
Yep.
And GPS
and for those of you who have not worked in mining autonomy before, this is going to be a treat.
Yep.
For those of you who have ever been told by a large company that you as a autonomy person take risks that are too big, this is going to be an even bigger treat.
Yep.
So with that said, let's play a little game.
All right,
so I have my laptop here with my 48 tabs.
What do we do in this game?
One of which, so this game that we play that Ilia reminded me I have to explain to the 3 of you who haven't listened before. We make up a robot, pulling from random a technology that we have to use and a business use case that we have to apply it for. Now, Ilia, there's a lot of medical robotics that are out there. I think it's a good field for us to get into.
Yeah.
Robots for surgery, robots for what have you.
Hair implants?
Yeah, hair implants, dentistry,
That's right.
barber haircuts. Now, a lot of these robots are teleoperated, and that is lame sauce, I think.
Or open loop.
Yeah.
Yeah.
And I think sensing a human is, a thing, especially when you want to be really precise. And on the other hand, I really like thermal cameras.
Okay. Okay.
So we're going to apply thermal cameras to healthcare robots.
Okay.
Yep.
For surgery, you want to do surgery specifically?
I don't know. What should we do?
I mean, that's
I don't
probably
know much about surgery, so I feel like kind of like Ken in the Barbie movie. I could just join an operating theater and hop on in.
You'll be fine.
But I don't know where in healthcare should we use these thermal robots?
So
thermal cameras.
Going on a quick tangent, really quick. There's a bunch of healthcare startups related to old folks care and palliative care and that sort of thing, and they're like, we're just going to put a camera, it'll monitor the person, and if anything goes wrong, we'll know. And it sounds great until you, meet people who don't want to have a camera looking at them all the time.
So there's actually a company for a while what they're doing was radar.
Exactly.
To see if
that's
old
what I'm
folks,
getting to. Yeah. It's like there's this whole pushback of I don't want a camera in my bedroom all the time, which makes sense. So what are other modalities we can use? Radar was one. Another one was so especially millimeter wave radar, which can detect accurately, are you standing, are you lying down? Another one was actually to use the ambient Wi-Fi and figure out absorption from Wi-Fi patterns to figure out if somebody's fallen over. But yeah, thermals is another one where it's you could make a case that it's at least somewhat less personally identifying.
I don't want to do senior care. My wife Cassie works in senior care.
Yeah.
I know too much about it for it to feel like too much fun, especially because it's the ultimate world of apply a $300,000 robot to replace a human who makes $20,000 a year on a good day.
Yep.
I think we should do some sort of operation or treatment or something using thermal cameras. Because what I'm interested in is if you have a really, really, really expensive thermal camera, can you do stuff on people using this part of their body is 98.3 degrees. This is relatively cold at like 97.4 degrees.
Oh yeah.
Is there clever stuff that you could do if you had just like I don't know how good a current thermal camera for robotics is, but let's say like we got like a super high end thermal camera.
So even surprisingly, even the cheap stuff, like the one you borrowed the other week.
Yeah. My home office is an uninsulated basement, and I've been freezing to death in it, literally dying every single day. And
not just on the inside.
Yeah, and I've wanted to insulate it somewhat. So I tried borrowing Ilia's FLIR thermal camera that plugs into your phone, and then it didn't work.
The app didn't work.
Yeah.
Yeah, it works. The camera works fine.
Yeah.
Anyway.
Thermal camera success, app failure.
Yeah.
Which is why every company should not make an app.
Yeah. So even a cheap camera like that, which is like $150, let's call it.
Yeah. I think buying the whole dongle is like $200.
Yeah.
Doesn't have a real battery, doesn't have a real compute.
Yeah.
Because it's doing all that on your phone. Like probably it's a $30 sensor.
Yeah. It's the little Lepton series. So even that's accurate enough where when I was testing it, if I pick up a can and then put it down again in literally a second, if you image my hand, you can see my fingertips have cooled down. Mm-hmm. So it is accurate enough easily for that. So if there's something that you're doing, for example, if you're implying a contrast agent for an X-ray or something like that,
but
the coldness of that fluid, you could see it probably with a good enough camera, see it trace its way through people's veins.
But then your tracing agent would be put a really cold fluid in people?
Yeah, I mean, like really cold as in like 5 degrees cooler than your body temperature. It doesn't, like, the cameras are really accurate.
But I wonder, I imagine, not knowing anything about medicine, there are some conditions where a side effect of them is temperature changes in areas.
Yeah, maybe.
So an infection, like when you have an infection, you have a fever to fight it off.
Well, you'll have a hot spot.
Yeah.
Right. So if you have an actual infection from like a wound, then it will get hot.
Yeah.
Yeah, I mean, you could use that to track.
And I feel like you could almost use like, if you could use a thermal camera to basically guide a surgery arm to cut out, like to do things when like an infection's going the wrong way, or like kind of be the feedback loop of how good are you doing.
I think, you know what we're missing here? Huh. Do you remember during peak COVID times, everybody had thermal cameras up to check if you're sick?
Yep.
I think they didn't have the enforcement arm. So, like, thermal camera checks if you're sick. Because now we're post-COVID time.
So you try to walk into a mall.
Yeah, exactly.
And you have COVID.
Yeah.
Thermal
Not even
camera.
COVID. No, you can't take.
Just make
you
COVID.
have a mild fever from your toddler that they brought back from.
So you try to walk into a mall.
Yeah.
Thermal camera sees you're at a 100-degree fever.
Yeah.
Robot arm pops out of the floor.
Yeah.
Sees where the fever is.
Yeah.
And it removes it from your body.
No. It removes you from the space. Politely at first, less politely the second time.
Actually, to think about it more seriously, zombie attack.
Right.
So a zombie bite, I assume, is an infection.
Yeah.
I mean, it depends on your zombie genre, but probably looks a lot like infection. You could and in some zombie movies, when there is such an infection, you can stop its spread by cutting off the damaged part. So zombie bites your arm, bites your hand. Your buddy saves your life by chopping off your arm with an axe.
You know what you could do instead of that? Just look for the bite marks.
No, because there's always like the kid who like hides the bite mark or whatever.
Oh, okay.
So thermal camera sees the zombie bite.
All right.
Spinning razor blade on
an industrial arm.
On an industrial arm.
Yep.
Pops out of the floor.
Yep.
Removes the infected area.
That's right.
So to build this, and like this.
And what's surprising is that also applies to zombie shoppers in a mall who are running a fever. Same level of effort should be deployed.
Yes.
Right. If you're running into a Black Friday sale.
If we're in some world with zombies, like imagine some like
Black Friday
sci-fi-ish zombie movie.
Yeah.
Where they're like kind of post-initial zombie apocalypse. They're now living with the active zombies, like a World War Z or that TV show with the mushroom, Last of Us.
Yeah. Oh, that's my favorite zombie,
Yeah.
by the way.
So let's say you're in a Last of Us world or
Yeah.
World War Z world or, whatever. Like society has recovered. There's pockets of humanity.
Yeah.
Your gates could be basically these robots that chop apart any zombie or chop off any zombie afflicted person. Cauterize the room while you're at it, or the wounds while you're at it. Why not?
Just lasers.
Yeah.
Or heated blades.
Yeah.
It's a robot arm with a saw blade and a flamethrower.
All right, so how would we design this system? So we're at the gate of some city that I'm sure would be called Babylon or whatever.
Yeah, sure.
In this zombie apocalypse movie.
Okay.
So we have thermal cameras pointing towards people entering into the gate. We can detect someone who comes out. How would we make this arm both be unobtrusive if like a truck had to come in quickly, as well as be able to pop out quickly to remove zombified flesh?
Well, I think at that point you probably want actually 2 robots.
Okay.
Right. More robots always solves real world problems. One is the robot arm itself, and the other one is a movable carriage. Okay. So a good one for listeners, if you want to see a really great demo from probably a decade ago now, is like Bot and Dolly did this for videos, where they took a robot arm and they put it on a movable base. And they used it for video film magic stuff. Yep. But in this case, you'd have a door that pops open, the base moves out with an arm, and then gets to cutting.
Yep. Just starts removing limbs that are
removing all parts.
Impacted. Yeah.
Yep.
Yeah. And whatever. It's a zombie future, so I think actually people wouldn't have safety concerns with this.
I mean, if anything, you have unsafety concerns. How efficient can it get the zombies?
Yeah. What are we going to call the gates of Babylon? 2000?
I think the main problem here is using a thermal camera when you've used the flamethrower to set your zombie on fire. Like, there's some level of exposure confusion.
Well, yeah,
here.
but at that point, you should be chopping it apart anyway.
Yeah. So it's just like
whatever.
At some point you hit the trigger and it's just everything here is on fire.
Yeah, and then it's all sliced and diced.
Yep, that's right.
All right, coming to a sci-fi movie about zombies near you.
I'll think of a clever name later.
Oh, no, Gates of Babylon.
Gates are...
I think that's a phrase, right? Yeah, 3000.
Yeah, always 3000.
Yeah. Ilia, let's talk about collision avoidance systems. So talking to you as a roboticist who has worked in robots before and not always just in mining. When you hear the words collision avoidance system and situational awareness, what would you assume that means?
I would assume that the robot has some ability to sense its environment.
Okay.
And stop itself from hitting stuff.
Okay.
Is kind of the 2 main things.
Okay. And when you think of like what a large and like let's struggle and make sure we don't name any specific publicly traded companies.
Yep.
When you think of a large billion plus dollar company who cares about safety, what types of concerns do you think they normally have?
You mean in terms of the mine site?
And in terms of like robot safety or like mine sites or safety engineering, like how do you think they design a system?
Well, yeah, I mean, it's kind of a loaded question because I know how they've designed the system.
or how do we think about safety?
What are you trying to lead me to?
How do we think about safety at Polymath in general?
Yeah. Okay. So,
or how do we think good engineers think about safety of a robotic system?
So I think the main principle you should have for a safe system, and we've talked about this before, is like you should have a minimum risk mode that the machine can fall to at any given time. Right. So whatever it's in the middle of doing, it should be able to very quickly transition, as quickly as possible, transition to minimum risk.
Yep.
Generally, for moving machines, that's standing still.
Okay.
But not always.
Yep.
Right? Like if you imagine a conveyor
truck
belt.
on a highway.
Yeah, truck on a highway, or if you have a complex machinery, somebody's gotten trapped in it, stopping might not actually be safe.
Yep.
But in most of our cases, moving machinery, stopping. The next phase you have to consider is how do you trigger that stopping behavior, and under what conditions can you fail to trigger it?
Yep.
And so our rationale here at most AMR or industrial robot companies is that you shouldn't have to depend on any external system, because if that external system fails, your robot now won't trigger its safety.
And like, how do you describe systems that you should be able to depend on?
So
or some systems you should be able to depend on.
Yeah. So we can get into like safety rating documents and all that sort of stuff. But the short answer is I have some way to determine how effective is my sensor at judging the risk, and how easy is it for it to get a false positive or false negative.
Yeah.
The false negative is the really dangerous one. So key example in factories, you have a robot arm, it's big, it's dangerous, it has no idea what it's doing because it has no onboard sensing.
Yep.
If a human goes near it, it'll get flattened.
Yep.
So what you do, the easy way, the old way to do it, is you put up a laser safety fence.
Yep.
Laser beams on one end, receivers on the other end. If you break the beam, just like your garage, it stops the robot arm.
And I think suffice to say, we should understand how that laser safety fence works.
Yeah.
And like that laser safety fence, if you stick something in between the emitter and the receiver, it should always trigger.
Yeah.
Like there might be weird like corner cases,
Yeah.
like if light is coming in from Jupiter with whatever.
All the modern ones are encoded and stuff. Like they're very high reliability.
Cool. So let me tell you about an amazing type of system.
All right.
And the system's so amazing that it is deployed around the world for lots and lots of money. So you have a bunch of vehicles in a mine site.
All right. So I put laser safety fences around each one.
No. Yeah, sure.
Why couldn't I do that?
You could, but you don't.
Yeah.
Instead, every vehicle has a high accuracy GPS.
Okay. So we're already depending on something that foreign nations are currently actively jamming.
Yep. And I think
And spoofing, which is worse.
And I think GPSs also aren't deterministic in and of themselves.
Yep.
Which we need to come back to and talk about as a specific problem with those.
Yep.
So everything has a high accuracy GPS.
All right.
Now, all those high accuracy GPSs are talking to a local cloud
Okay.
and sharing the information on all the other vehicles' locations
Wirelessly.
wirelessly.
Okay.
Yep.
So now your wireless system is part of your safety protocol. All right.
Yeah, the T-Mobile guy, can you hear me now? Except you die if you can't.
All right. Great.
And what I just described is in mining called a collision avoidance system or a situational awareness system.
All right.
And that is the primary safety system of these autonomous systems.
So let me get this straight. The machine doesn't actually sense anything around it.
So they do, but it's like a distant secondary system.
Okay.
The primary thing is there's an assumption that every single thing that moves has a high accuracy GPS constantly publishing its location to everyone else.
So everybody on site has to wear a backpack with an antenna.
Or they can't get out of their cars. Or if they get out of their cars, you need to shut down the mine or shut down the local area around the mine.
Yeah, I mean, guys who are working 30-hour shifts way out in the boonies in Australia are famous for following regulations super accurately.
Yep. Yep.
So, interesting.
Yep.
By the way, if for listeners, if you want to see, there's a few good videos of ultra-class mining trucks flattening 4x4 cars and not even bouncing at all. Like they just completely pancake them and don't even stop. So that's the level of risk you're talking about.
Yes. This is a absolutely bonkers type of system. And what's interesting is like the proponents of these systems will often rip you apart for, thinking things like machine learning aren't reliable enough. But while having compounding non-determinism in GPS, non-determinism in their networking, actually a significant problem that many companies, autonomy teams in mining face is that their networking becomes the blocker of how productive their vehicles can be. Because anytime there's a networking blackout or something doesn't work, every time there's some flavor of a networking blackout, whole chunks of the mine have to stop. Which means many of these programs struggle to be 100% as productive as human-driven vehicles.
Yeah.
Just because of networking in mines.
Yeah, exactly. We've heard a good story where one of the groups puts a bunch of sensors on their ultra-class mining vehicle, and because they follow this process where they stream all the data to a cloud, on-site cloud or kind of server, on-prem server, they took that same approach to LiDAR data, and they stream so much data that as this autonomous vehicle passes by, every other network in the vicinity has to downshift any bandwidth usage to provide enough airspace.
Because they're live streaming every single point cloud over this network, this safety critical network that everything relies on to not run people over.
Oh, I mean, there are ways. So from a pure safety perspective, to stop poking quite as much fun at them. From a pure safety perspective, you can make wireless networks safe. What you can do is you can make sure that every message has a unique signature, a key, checksums, timestamps.
And I wouldn't be surprised if these parties have done that.
Yeah, I'm sure they've done at least some level of this, right? The catch is that if your default safe behavior, as I mentioned, is stopping, then anytime you have a network blip where you miss the update rate required to keep the system active, the only sane thing to do is stop. because you no longer have any idea where
But
the
when
other vehicles
stopping
are.
costs tens of thousands of dollars a minute,
Yeah.
you suddenly have this trade-off, this very direct trade-off between a tech limitation imposed safety requirement and making that Skrilla.
Yeah, I mean, I can imagine maybe not the ultra class mining vehicles themselves, but some technician's truck that has one of these systems and his engine dies or his battery runs out. He will fall off the map. Right. Or the antenna gets disconnected. He'll fall off the map. And if you want a strictly safe system, your only choice is to stop all motion anywhere near him at that point. But I doubt that's what actually happens, right? So at that point, like, you now have an undefined scenario pretty early in the deployment process and a fairly straightforward failure mode that I'm not sure you can fully account for.
We've also seen versions of the system where the vehicle's footprint is inflated. And it needs to operate near some hazard, like a cliff edge.
Inflated as in the footprint is made to be bigger than the actual vehicle.
Yes, like
as a safety margin.
25 to 50% bigger than the actual vehicle as a safety margin. There's some hazard, like the face of a cliff, which, you know, is also reasonable to inflate. And now you have two things that can't happen around each other because the vehicle needs to work by the cliff, but it can't come within, outside of a very particular attack vector, it can't come close to the cliff. Especially if for some reason both of the things are made to be squares. Suddenly have a corner that you can only drive to in a very certain way, or paths that you can only get to with really weird, complex, inefficient behaviors in use cases where every minute can cost tens of thousands of dollars.
And I think the answer we've been getting from a lot of people in that, you know, mining seems like a perfect use case. High value. High safety risk,
big labor shortage
problem, all the good things where autonomy. But why aren't we seeing, you know, nearly fully automated mines, not fully automated mines? And I think one of the reasons is historically it's been such a good use case that a lot of investment went into it early
in 1995.
1980s, 1990s, early 2000s, and we're kind of stuck in that mode because it's just barely good enough.
And I also think, like, way back then, this was kind of a reasonable way to get something out the door.
Oh, you had no choice. LiDARs didn't exist in any sane cost. Machine learning was...
I think LiDAR, like, probably... I mean, the 2004 DARPA Grand Challenge is when it was invented.
Well, three-dimensional LiDAR.
Okay, sorry.
2D
so 3D LiDAR was invented for the 2004 Grand Challenge. And these systems were being deployed in mines at that same time.
Oh, exactly.
So this was the only way to know how to not run stuff over.
And you know, a tip for everyone out there, two-dimensional LiDARs in a three-dimensional world is a bad idea. You know, I think, again, people have taken what they had access to, which was two-dimensional LiDAR safety curtains by SICK, for example, that are great for factories, and they're even great for AMRs that move around factories. But factories tend to have almost laser-perfect level floors.
Which is why you need humanoids to walk around them.
Oh, exactly. So they tend to have laser-perfect level floors, and so you can get away with a 2D slice of the world and have a good understanding, especially if you put it, you know, roughly one height of a foot off the ground. You'll catch everybody's feet, and you can guess where the person is from their feet. The real world, especially on a mine site, your ground is going up and down. And so if you try to stick a 2D LiDAR on there, you're going to get a ton of noise. And then you have this problem of, how do I perfectly estimate the orientation of my vehicle at any given time in a safe way, fast enough that I can detect a person? At which point, then you're making a trade-off of either my system is so conservative it's not usable, or it's so aggressive that there's giant blind spots that you can fit a person through pretty easily. And so in a lot of ways, the approach to outdoor safety really had to wait for modern radar, like millimeter wave radar or automotive grade radar, modern LiDAR, modern machine vision. And that's only kind of starting to pick up now. And a lot of the kind of legacy players, they're starting to. I mean, again, there's a lot of groups that have put a lot of money into this, but they're now encumbered by this legacy tech stack that takes a long time to change over from.
And I think there's also a business structural problem that also created this. You'll note that, like, most of these companies were and are super vertical. So they're building the vehicle. They're building the autonomy stack. They're building the fleet management system. Oftentimes, they were delivering this as a service by putting a bunch of forward deployed engineers. They might also be building all the networking. They were also building this collision avoidance system, which means there wasn't really when you have like 2 or 3 vendors in the world for a product like this as a mine, they can't, and you have a matrix of things that they do that is, 100 criteria for how to choose which one that is hundreds tall.
Yeah.
Innovating or being thoughtful on slightly better safety system design is not a path to success for either of those companies.
No,
it seems like, this type of system where everyone reports where it is, it works good enough.
It's fine.
Just like get better at networking.
Yeah.
My home Wi-Fi has gotten way better in the last 5 years.
Just get a little bit more reliable.
Yeah.
And I think our producer Nicole mentioned that she was talking to one of the large manufacturers, and they said like, "Oh, why should we care about whatever problem she was talking about? We make more in merch sales than we do in like anything related to this field. Why would we ever care about putting effort into this?"
Yeah.
So I think it's that.
And like,
right?
if you buy these autonomous systems from these big companies, like you have to buy these collision avoidance systems.
Yeah,
in some places, like Western Australia, it's written into law that you need a collision avoidance system. So the fact that it's like built the way it was built based on assumptions in 1995 is, if anything, it just means less technical effort from the supplier.
Yeah, and actually, you bring up another thing, which is vendor lock-in has been a huge problem.
Yeah.
Especially, again, in mining, but agriculture sees the same thing, where you buy, for example, a John Deere tractor, you have to get service from John Deere, and you have to get parts from John Deere, and you have to have an approved John Deere vendor for ABCD.
Yep.
And mining is just like that. And so one of the reasons that it hasn't expanded, another kind of related to we make more in merch sales, is that why would large mining equipment manufacturer A ever put any effort into integrating with mining manufacturer equipment B's equipment? Like, why would they ever?
And in fact, like, there's a couple of stories where that's happened, but it was like a one-off consulting project that worked once.
Yeah, exactly.
Like where one of them paid a whole bunch of money to a third party to make someone else's equipment work with theirs as a press release stunt, and that's not really a thing you can buy.
I mean, how much money did BHP sink into their own autonomy program?
So what I have heard,
estimates, obviously.
So what's actually funny about this is like most of the listeners probably have no idea who BHP is.
Yeah.
So BHP is a mining company, mining conglomerate with a market cap, I believe, in the range of $250 billion.
Not bad.
Yeah. So they are bigger than all but like 15, 25 tech companies.
Yeah.
They are absolutely massive and basically unknown in Silicon Valley, outside of like people who happen to work in mining. They were so fed up with this lock-in from the major mining OEMs that, to rumors that we've heard, they spent something like $100 million trying to build a OEM agnostic autonomy system, and ultimately got like weird political games from the big OEMs because there's only those two who you can buy from.
Yeah.
Which then goes back to the like, oh yeah, I guess you can just put up with like absolutely terrible safety system design.
Yeah. Yeah. So speaking of which, GPS in safety systems.
Yeah. Well, like my GPS on my phone works great. Why can't you make that safe?
Yeah. One of the cool diagrams I made a long time ago was I just took like a GPS receiver, stuck it outdoors, and just left it there like a site survey.
Yep.
And that's basically how RTK works, by the way, is you set up a base station, you let it survey over a long time, and you have this kind of moving baseline of what is the ionosphere and atmosphere, how is it distorting your reading?
What's the ionosphere and how does that impact GPS?
So just distance from your satellite and the temperature and weather will literally deflect your beam enough that you get slightly different readings.
Yeah.
Like these are readings that are, because remember, what's fun about GPS is it's accurate enough that you have to even account for special and general relativity.
I didn't realize that.
Oh, yeah, because the satellites are moving quickly.
Well, yeah, I mean, like, to put it in perspective, a GPS satellite is, 25 miles off the surface?
Yeah, some number.
Sounds seem reasonable?
Yeah, but they move, right? They're not in geostationary.
And they're probably traveling, they're how many Earth rotations a day? A couple?
Probably 9 to 12-ish.
Yeah.
I don't know the exact number.
So that means they're probably traveling in the range of 3,000 to 6,000 miles an hour.
Yeah.
And for me to know exactly where I am now, I'm not like the smallest guy. But for something traveling 5,000 miles an hour, 25 miles away from me, to precisely know where I am means that every single thing needs to line up so perfectly, that like a little bit of bounce might change that distance by a foot or two, or 10 feet.
Yeah,
and like going back to my joking statement of like, why can't I just rely on my phone GPS? If you've ever opened up your phone GPS to order an Uber or what have you, and it thought you were at the end of the block, that's an example of when you could die.
Yeah.
That would be death if that was a safety system.
Yeah.
Because at the end of the block, if you're making that as a decision to not drive forward, might mean oh no, you are now in a wall because you're accelerating towards somewhere slightly away from that.
And there's tricks that if you have maps open when you're driving, there's tricks that you can do there where you fuse in the IMU from the phone, and you fuse in a priori knowledge that you're on this street and the street looks this way, so it's very unlikely you just jump 20 feet that way into a house. So there's all sorts of tricks, but at the end of the day,
but if you remember like older GPSs, that would totally happen.
Yeah, exactly.
Like your Google Maps app like 15 years ago would like halfway through driving try to redirect you because I thought you were on a side street now.
Yeah,
and it's mostly just like pretty straightforward software engineering that solves that.
Yeah,
not like GPS magic
and better GNSS. Like since another thing that's changed in the last several years is a lot of countries have started launching their own satellite networks. Mm-hmm. So now you have obviously GPS, the kind of sort of original, but you have the European one, Galileo. Yep. China has one, Russia has one. Mm-hmm. There's a few others. Most GNSS receivers now will pull from all of these networks simultaneously and get a better corrected value. So some of it is improved GNSS technology, but some of it is just fusing in IMU.
Yeah, I mean, like our office is close to it, and for much of the last 10 years, I've lived close to an area where there's a surface street underneath the highway.
Yeah.
And 8 years ago, if I was using GPS to get somewhere embarrassingly close by, it would start to think I was on the 101 while I was very clearly on Division.
Yeah.
I had driven from a place where I could not have gotten onto 101, and now that basically no longer happens, primarily because of
the tricks,
software tricks.
So coming back to it, you put a GPS stick outside and you start getting measurements. And what you'd think was that if you get this nice Gaussian distribution of just guesses, throwing darts at a dartboard. But in reality, because of these atmospheric effects, because of other kind of reflections and your local interference, you'll get this kind of weird distorted teardrop shape.
Huh.
Like almost like a swirled teardrop. Okay. Is a kind of a classic shape. And you'll get most of your readings close by, but you'll get a pretty decent clump, kind of this long tail. And so you can't just take a crappy GPS value and fix it with math or statistics. You have to have either an external source like a real-time kinematic fix, RTK fix, or other tricks. All that to say, you can get more and more accurate GPS, but the fundamental problem of multipath reflections, of ionospheric interference, of just being covered because you're next to a rock wall or a metallic building, all of those play havoc in your readings, and there's not much in the GNSS itself that can tell you when it's far off.
Yeah.
It can make guesses.
Yep.
And those guesses are very useful. And really good systems will tell you, here's my rough tolerance. Or covariance, or depending how you're processing it. But it's very unlikely that GNSS system will tell you, I guarantee you're here.
Yeah.
And if it can't guarantee it, the question then is, how do you, not even guarantee 100% of the time, but guarantee in some 1 per million failure rate, how do you build that into your safety system? I'm not sure. So we've kind of made the conscious decision not to pull GNSS into safety. Mm-hmm. We use it external, we use it on our path planning, we use it geofences, those sort of things. But for the low-level safety layer, we do everything robot relative.
Yeah.
And we build up an odometry frame. And that's all that is not even to start on the topic of how much jamming and spoofing has been happening. And I would argue spoofing is more dangerous. Because if you just jam something, the system can go into a default safe state. No signal, I don't know where I am, stop. But if it's spoofing and telling you you're somewhere else, that's very serious.
Yes, weird things happen quickly. So how outside of fully making safety the onboard responsibility of an autonomous vehicle, how would you design or how would you think about a collision avoidance system where you wanted to say make safe that pickup truck that was operating in a mine around a large vehicle?
Yeah. So I think I do think there is a place for traditional collision avoidance systems for networking, because one key thing they do give you can't really get anywhere else is the ability to see around corners.
Yep.
Right? If I have a good guess of where somebody else is and that's been relayed
that can be pretty powerful in terms of my freedom to go around a blind corner.
Exactly. I can preemptively slow down. Those sort of things. So I think that's one good input.
Yeah. Which might in some way look like very special zones on a map.
Exactly.
Yeah.
I've now entered the zone. Again, not from a safety layer perspective. Safety should be independent of it. But I've entered a zone where I know I should probably reduce my maximum speed because I'm coming up to a blind corner.
Yeah. Or even just if anyone has gone dark in this zone, the zone shut down.
More caution.
This blind corner is done, or this blind corner max speed is now such that stopping distance is 5 meters or something.
Exactly.
Or what have you. It's like a relatively straightforward logic tree.
Yeah, exactly. But otherwise, designing for safe systems, you have to consider your hazards and risks. You have to consider your use case, your ODD. But really, the main thing I keep coming back to is there's no single silver bullet sensor.
Yeah.
And so using a mixture of sensors that can be robust to different weather conditions, different use case conditions, and understanding the strengths and weaknesses of each sensor and building your safety system that takes that into account.
Yeah.
Like I cannot, giving a concrete example, radar is very good at dust.
Yep.
You can see through dust and rain pretty well.
Yep. But they're not even there.
Right. But I cannot depend on radar to give me accurate positioning of somebody close by.
Yep.
And so if I see a pedestrian way the heck out there,
we'll see them if they're no problem.
Great. But as they get closer and closer, as they get closer and closer, I should start to depend on that reading less and less and less.
Yep.
And switch over to other sensors, which will give me a better, more accurate reading of where that person is.
Yep.
And that makes sense from a design perspective. If you're speeding truck, if I'm going in a particular direction, I really want to know what's in that direction as far as I can to give me enough time to stop.
Yep.
But as that thing is getting closer, I should slow down and start to go around it. And then I really care about how close is it to me? Is it about to step into my path?
And which sensors are better for that? And for localization, I mean, like we've talked a lot about ground penetrating radar as a deterministic localization sensor.
Yeah.
How could we think about making that connectivity closer to deterministic? Or how could we think about that problem?
Network connectivity?
Yeah.
So network, I think I mentioned this a little bit earlier. I think networking itself is hard to make fully deterministic, but you can defend against it by building in safeguards in your messaging itself.
Yeah.
And there's a whole list of safeguards, but it's everything from defending against spoofing by having encryption keys, having IDs on things, having timestamps, all the way up to picking your actual network architecture. If you're using classic TCP or UDP, the trade-off is, and this is kind of funny, UDP always sounds better for these kind of designs, but the vast majority of modern network infrastructure is built and optimized for TCP. So if you're using commodity switches and networking gear, your TCP stuff will work better, even though theoretically the UDP stuff should work better. But there's a bunch of trade-offs there on how you structure a message. But I think one of the things that the safety standards do say is that you cannot depend, unless you're buying a certified system, which I don't know of any safety certified networking solution.
Yeah, we haven't come across it yet. If you have one for sale,
send us.
Please reach out.
Yeah.
We would love to send you a lot of business.
Yeah, we will happily chat with you. But given that doesn't exist to our knowledge, you can't depend on the headers and checksums and timestamps of the actual networking layer. You have to build your own that you can then independently verify. So again, if the network is down or confused or attacked, you have your own independent way to verify the validity of the messages you're getting. And that's basically how you can make a network more safe.
Yep.
Now, you still have to think about redundancy. You have to think about performance. But at least that's the first step.
Yeah, so that's collision avoidance systems. I mean, I'd say I was pretty jaw-droppingly shocked when I started learning about what the state of the state is out there for this, because some of it is so obviously how you should be concerned about a system being designed, and the fact that it is almost arrogantly promoted within the industries that it serves is an interesting state.
I probably, maybe I shouldn't say it, but I'll say it anyway, and we'll cut it if we need to, is I'm willing to bet if there's a state actor targeting another state with a large mine that has some of these systems deployed, it would take one dude and $1,000 worth of equipment to drive any one of those equipment off a cliff.
Yeah.
By just coming up, spoofing the GPS and attacking it specifically.
Yeah.
I mean, we know of state actors that have taken down military drones exactly this way.
Yeah.
They've targeted it, they've spoofed it to think it's somewhere else, that it's over a friendly airbase and landing when it's not over a friendly airbase. That attack costs $1,000, maybe $2,000 these days.
Yeah.
You could take out a multi-million-dollar mining operation.
Yeah, which is pretty real, given that many of these companies buy spare parts from criminals who stole them from their competitors. Or have been rumored to do so. We've never heard conclusive proof of, but
nobody's been charged for this.
Or no, that we know if it's been charged for it. It seems like a pretty straightforward way to disrupt service.
Well, with the new coming back to American politics,
on that note, as a fun thing to close out the week, or close out the podcast, have you heard of the 4-color theorem?
No.
Neat thing I learned of the other day. Basically, the 4-color theorem states that any map in a plane can be colored using 4 colors.
Yeah. Sorry, I haven't heard of this.
As long as they don't all connect on a single point.
Yeah.
And essentially, you can always use 4 colors to make a series of shapes touch each other where they never touch the same color themselves.
Yep. Yeah.
Yeah,
it's a good topology math problem.
Which,
there's all sorts of fun.
Broke my brain a little bit. I ended up watching a video on a mug where a bunch of mathematicians were drawing to connect 3 utilities to 3 houses, realizing that you couldn't quite outside of an interesting trick.
Nice.
But yeah, listeners, not related to robotics, highly recommend. Go look up 4-color theorem, and especially this mug for three houses, 3 utilities, and make them all match, touch each other without any of the lines intersecting.
Cool, man.
Yeah. With that, we'll see you next week.
See you next time.